Welcome everyone to EA Global Summit 2021. This is Sujat from EA Global Summit organizing team. It's our privilege to have David Hetherington in our presence, the head of research and development, over 10 years of experience as a manager and consultant, 15 years of experience in modeling safety critical system and enterprise architecture, over 20 years of experience in software and system architecture, presenting Sysml Quick Start using Enterprise Architect. And I also thank everyone for your interest in joining the session and for your kind information that we will be muting all the participants throughout the session. So please use the chat window to drop your questions to the speakers. Your queries will be answered at the end of the session. We request everyone to visit the allotted Microsoft Team channel to communicate with David and the other EA practitioners after the session. David and the other EA speakers accepted to stay in the channel to have a one-to-one discussion and answer all your queries. The link to the MS Team channel is posted in the chat window for your quick reference. If you have any difficulties in connecting to Teams, please let us know through the chat window or write us at registration@eaglobalsummit.com. Thanks once again for your interest and support to EA Global Summit 2021. Without any further ado, I'll request David to start his presentation. Over to you, David.
Yeah, good morning or good evening, depending on where in the world you are. I happen to be in Austin, Texas, and it's good evening here. And yeah, we're going to spend most of this session. I'm going to in the tool. I've just got a few slides here or more where to get more information. I'm going to show you a couple things quickly, and then we're going to jump into the tool, and we're just going to construct a model, and I'm going to walk through that. And then at the end, I'll put this information back up one more time for anyone who comes late to see where we can get this. And in the Teams here, we can see there's a channel for this session. And this little presentation, which we've got up on the screen right now, is available in the files section of that. If you're familiar with Teams, you can just go get the presentation. Like I said, it's not really the main content. The main content is this tutorial we're going to walk through, but that's downloadable as well, which I'm going to show you in a minute. So first, Sysml, one of the first things is, well, you've got to have the right edition of Enterprise Architect. These three have it. This lowest end one does not. So if you'd like to do Sysml, you need at least the corporate edition in order to do Sysml. The Unified and Ultimate editions have more features like simulation. However, you don't need them at the beginning level. If you're just going to do the beginner's book, which I have, or this tutorial, all you need is the corporate edition. For downloading this, the tutorial itself, this tutorial that you're going to do is actually just Chapter 2 of the book, Sysml for Beginners Using Sparks Enterprise Architect from Asate Press. And when you go to the website here, asatepress.com, you go to Downloads and Tutorials, and you can pull down the book, or this tutorial, as well as some installation notes and sample models. Now, I could talk a whole hour about Sysml. Sysml is a system modeling language. It's developed by NCOSE, the International Council on Systems Engineering, and together with OMG, who serves as the standard body. The big thing I want to get to, though, before we start, if people are really unfamiliar with Sysml, is Sysml is not a PowerPoint compiler. So this is an example from my book about the little company that's trying to make a pay-as-you-drive insurance box that would mount under the dashboard of a car. And because it's high volume, it probably has a custom designed chip. Of course, it has a housing. It's got some embedded software, a board. There's marketing. It's going to need a cloud interface for a customer. So there's a cloud application. Well, there's a web interface, and even data privacy laws might affect it. You know, what about your driving data? Can anyone see that? Ethics. What if the car is speeding right near an elementary school? Should you call the police or not, right? So there's an ethics and so on. And the thing about these is the purpose of Sysml is to form the minimal, clear understanding that all of these different stakeholders can go back and use their tools, because every single one of these stakeholders has some specialized tools. Mechanical engineer has a CAD system, accountant has accounting tools, lawyer has databases, and Sysml does not replace those tools, and it's not the intent of the systems engineer to do these people's job. It's only to sort of facilitate the common understanding is really what we're trying to do. Here's the book. I'll put this back up. You can get the whole book if you want it, and this is questions, and I'll put this up at the end again so we can take a look at it. Okay, so with that out of the way, now we're going to make a model, and I'm going to go a little slow. So maybe for this session, maybe someone has never even seen Enterprise Architect. So this is Enterprise Architect 15.2, and it comes up. I've got the perspective set to Sysml down here in the lower right-hand corner. If it's not set that way, you can set it up here by managing perspectives and selecting it and selecting what you want. We've got a start page. I usually don't use that, so I stop that here. We're going to make a little doorbell system. So with this started, the first thing we're going to do is create a doorbell system. So we're going to do just like any other thing. You make a new project here, and here we're going to do this. We're just going to call it doorbell. And because the Sysml perspective is set down here, this defaults to being a Sysml model. It's good practice to rename your model. You don't have to. A model will work without it, but your Sysml model is all about communicating with humans. It's not something you try to compile. So you want the model to be as easy for people to understand as possible. So it's good. You want to, first of things first, you want to name the model so that people can understand what kind of model they're looking at. Now, we can just start putting elements into the model, but it's a really bad idea, and no modeler does that. You instead organize the model in packages. And packages are just very much like directories in your Windows file system. You can think of them as a little file system within the model. And you make a hierarchy of packages so that you yourself and later other people will be able to find what they're looking for in the model when they come to look at it. So the first thing here is we're going to start off and define some hardware. So we're going to add a package, and we're going to call this hardware. My tutorial doesn't have this, but I'm collaborating with several consultants, and one of them from Germany pointed out that this is really a nice practice to actually identify this. Otherwise, this model can get very quickly get hard to understand. So I've now taken in the last year, I've picked up his practice of naming packages PKG at the end, so you can see that you're looking at a package. Yes, there's an icon there, but that icon isn't the most visible thing in the world. So now we know that that's a package. So we've got a package there, and we're going to, there's several different ways to do things. We're going to do it by just making a diagram right away. And the Sysml has 9 different diagrams. We're going to use one of them called the block definition diagram. And we're going to make the doorbell system context. Now, you'll notice that this says block definition diagram. If you're not familiar with Sysml, you might think, aha, the block diagrams I've always been drawing as a hardware engineer. This is not really what a block definition diagram is. The block definition diagram is more like the bill of materials diagram. It lays out the relationship of types of things and how the types of things are structured in terms of relationship to each other. So here you notice I've named the block definition diagram doorbell system context. This is one of the first things you make is a context diagram where you want to describe both your system, not all its details, but at least the system and probably the couple top level subsystems. And then you want to describe the things around the system as well. So we're going to use here the block. And a block in Sysml can be anything. We can think of it as thing, or actually more specifically, kind of thing. Yes, it can be a piece of hardware, or it can be a system, it can be software, it can be a political party, it can be anything, a recipe for cooking donuts. A block can be anything you want, and Sysml is completely flexible. It's not built around any one kind of design. So here we're going to define the doorbell system. Right, so there's our system. That's the system we have. And the system has two major components. We're going to have the button. Whoops. Just make sure I'm doing this consistently with my own Oh yes, doorbell button unit is what I've been calling that. There's a button and there's a chime. Now, obviously there needs to be a relationship here between these two things, and Sysml provides for a number of kinds of relationships. And the one we're going to use, this is the one the most used for the structure, is what's called a part association. And we draw that from here to here. And you'll notice the word part appears. We got a little compartment that says we've now got these parts. And we now have said that the doorbell button unit and the chime units are part of the doorbell system. However, understanding what Sysml is doing, this is not quite what you might think as a beginner. Beginners will tend to think of this as something like Fabergé eggs or Chinese boxes, that you have a thing within inside a thing within inside a thing. And there is some truth to that. But really, when we talk about a system like a car, when you talk about an engine, the car has an engine. The car really has the mounting holes for an engine. And the engine may have an oil pump, but it really has a mounting bracket for an oil pump. And when you go to manufacture a car, you've got to go say, all right, I've got the car ready, I need an engine. So you now turn to some other company that manufactures an engine. That company makes the block and so on, says, I now need an oil pump. And they get from another company, they get an oil pump, they bolt it into the engine, then they give the finished engine to the car maker who bolts it into the car. And this is what the part relationship is like. It's really the kind of the mounting bracket for a part. And we think of this in terms of the role that that will be played. So here we see the role in the doorbell button unit. We're going to say this is the front doorbell. I've certainly had houses in my neighborhood when I was a kid that had buttons and different chimes for the front bell for guests and a different bell for neighborhood kids to see their family's neighborhood kids that was on the back porch. So you may have more than one doorbell button in your doorbell system, and likewise you may have more than one chime. So we're going to have here, this is the kitchen chime, and so we're not going to show it today, but yes, you absolutely can model multiple kinds of chime, multiple instances of chime unit for them. And this is one that there's a role for a kitchen chime unit. And when you construct the doorbell system, you have to construct a doorbell button unit and a chime unit and assemble the whole things. And that's kind of the meaning of this, this diagram. So this gives you then the basic structure. And and now what we're going to do is, what about the humans? Well, we've got this thing called an actor. Any of our listeners who've ever done software use cases are may be familiar with actors. We're going to call this actor the visitor. And here we notice that the visitor is in the context of the doorbell system, but is not part of the doorbell system. These two things are part of the system. This is not. This is just the thing in the context that the doorbell system has to interact with. So there's no connection here, but they are in the diagram. And now we see over here, this is what's called the browser, and some places call it the containment tree. But here we can begin to see these things are showing up, and oh, we've got a visitor in the hardware package. That's probably not really what we want. I mean, it's quite okay, but let's add a package called actors. So now we have a package of actors, and we just drag the visitor over there, and everything works. But now notice here, this thing gets a notation on this diagram that this is from the actors package. These do not, because they're in the same package. Here's the diagrams in the same package as this. Also, we see over here, here's the doorbell system, and notice it's underneath in the browser. We can see the front doorbell unit and the kitchen chime unit now as parts of the system. So that gives us the basics of setting up the structure or the bill of materials for the system. And now we want to think about some requirements for the system. Okay, so we're going to add a package called requirements. Whoops. And here in the requirements package, we're going to add a diagram called doorbell system requirements. And the Sysml has a diagram for requirements. It's actually almost identical to the block definition diagram, but it provides some additional relationships, which we'll see in a minute. Okay. And now we've got a requirements diagram, and we're going to make some requirements. And here in these downloadable examples, I've got a little table of the requirements for our doorbell system. So here we've got a chime tone, and we got a chime cycle of, it's going to ring 3 times, and once you press the button, you're going to do 1 chime cycle. And this is a feature I always find annoying. You walk up to someone's house, and you press the doorbell button, and you don't hear anything because the house is pretty well sound isolated, and you can't tell whether that button's working or it notices that you are there or not. So our doorbell system is going to have a nice function. When you push the button, it's going to start flashing to let you know that it understood that you've pushed the button and that it's rung the chime. And so the button's going to be bright but to no, and when it's done, it's going to return to a dim glow, so you can find it at night. So we're going to have some states here, and we've also numbered the diagrams as you with some kind of a nomenclature. This is I recommend. Random numbers for requirements gets unmanageable very quickly, so you want to think through a numbering plan. So now over here, we're going to go back and we're going to create our first requirement. So we bring a requirement over, and here and it's also the other thing, if you've ever worked with requirement systems like doors, IBM's door system, they often don't set up to have you have a name for a requirement, but you really don't want this as the name, because over here, that's going to become quite unmanageable. So you want to have short names for your requirements as well as the text. So here we open this to set up the requirement, and the first thing we get is the short name, the chime tone, and we set that in here. There it is. This requirement is for the chime tone. Okay, so that's good. We got a requirement for the chime tone, but wait, where's the number and where's the actual text? So we go over here. And in a previous edition of EA, these 2 things were there. Recently, they've moved over to the tags tab. So we go over here, and we now take the number, and we put it in the ID. And we can come over and take the text and we put it in memo. So there's the text. We see okay, but it still doesn't show up. So it turns out one of the little subtle things you have to know is those things are something that UML calls tags. So you have to go to the compartments. There's lots of compartments that can be visible, and you got to turn on tags. And now here we have requirements. So there's our requirement. It's got an ID ch1, it's got a name chime tone, and here's the text of the requirement. There are six requirements. If you've got the Ultimate Edition, you should be able to load them directly from the spreadsheet right into the tool. I'm not going to do all six in this tonight, but I'm going to do one more because we're going to need it in just a second. So I'm going to do this idle dim glow requirement. So we're going to make another requirement here, and take the title. Idle dim glow, and we're going to go over here to tags. This one is BTO3. And we're going to go get the text. The button's going to glow dimly. We're going to come here and set the compartment so that the tags are visible. And now we've got this second one. Now we notice, well, this is great. So we've got some requirements on a diagram. Why would we do that? We can just keep them in a spreadsheet. It's much easier. To understand the usefulness of Sysml and diagrams, we have to make another kind of another diagram. So we're going to make another one here. So we're going to add another diagram called idle dim glow details. So now we got another diagram. And now we're going to bring, we're going to bring that idle dim glow, idle dim glow back on here, and we're going to again set the compartment visibility to show the tags. Okay, so now we've got there, and now what we're going to do is, which thing in the system has to make this so? Well, that would be the doorbell button unit. So we're going to drag that onto the diagram. And you'll notice here, it notes that this is a visitor from another package, and it's the hardware package. And now we get the interesting thing about requirements traceability. This has to satisfy that. And so now we can actually show this on a diagram. So this unit has the responsibility for satisfying that. And in a large system, there will be thousands of requirements and hundreds of different components in the system. And these diagrams can get, well, first of all, these relationships are really important. If you're doing a safety critical system, they're required by every safety regime on known demand, wants to see your requirements traceability, and that you can prove that you know for each component which requirements it has to satisfy. So this relationship works, but all these others are also useful. Like we can put a test case in here and say that this verifies a requirement. So we might make something like dim glow test. And we might say that this verifies that requirement. So you can construct the relationship, and sometimes requirements get kind of complicated. We get conflicting requirements from different departments, and we can refine them or show the two conflicting requirements on a diagram and then show what the final consensus requirement was by these kinds of relationships, and then who has to satisfy it. So this is a very important part of Sysml of getting all the different stakeholders on one page of who needs to do what. And yes, you can do it by spreadsheets or even directly indoors, but those get very hard to read very quickly. And these things can be very, very helpful for, especially for a validation engineer to know what things the tests need to handle, right? So, okay, so now we've done some requirements. And lastly, we're going to do a behavior. So the Sysml has three kinds of behavior diagrams. It has an activity diagram, which is basically a flow chart in your conventional thinking. It has a state machine diagram, which can show states, and it has a sequence diagram. Sequence diagrams are very helpful for getting a lot of stakeholders on one page about how the system is going to work. So we're going to make a system diagram, a sequence diagram, to show what happens when the visitor arrives. So now we're going to add another package. We're going to call this behavior. Now, there are many different ways to organize your model. I'm just got one here. This I like to tell people when they ask, well, what's the absolute right way to organize your model structure? And I paraphrase Bruce Lee, who is said to have said essentially, good form is what works, when asked about what was the best kung fu form. And this is the same thing. Your structure of your packages has really got to be easy for your particular stakeholders to understand. And some people do it by project phases, some do it by subsystems, some do it by logical versus physical design, lots of different ways. At any rate, I've got a structure here. We're putting the behavior in there. And now we're going to do this correctly. We're going to add an element called an interaction. And we're going to call this, you can actually create the diagram directly. The tool will let you, but this I got some feedback from readers in Japan of my book that strictly speaking, the standard requires you to create an interaction element and then create the diagram within that. And that reader is right. That is what the standard asks you to do. So we're going to do it the right way. So now we've got something called an interaction, and this has created a diagram for us. Unfortunately, this has created a UML diagram, not a Sysml diagram. So we're going to delete that. And now we have just the interaction, and we're going to add a Sysml diagram for sequence. And the main difference is the Sysml diagram is going to have the frame around it with the Sysml. So here we have a sequence diagram for an interaction, and it's a visitor arrival. So now we get the first element is the visitor. Bring the visitor over here, and we notice, okay, the visitor shows up at the top, and then this dashed line appears. This dashed line is what's called the lifeline, and this, we can visualize time starting at the top and flowing to the bottom. And so we're going to show what happens to the different elements as time goes on, time progresses here. So the two elements we're going to be concerned with are the doorbell button unit, and we're going to put that next to the visitor because it's the thing the visitor is actually going to interact with directly with a finger. And then we're going to show the chime unit. Space these out to make some space. So the first thing that happens here is the visitor walks up and presses the button. So we make a message that flows from here to there. Now we got a message, and we're going to name that. We're going to say button pressed. Now we're going to notice though, this little solid triangular arrow has the meaning of a synchronous message, i.e. the visitor would have to stand there holding the button until someone came to the door. And we really don't want that. We want something more like dropping a letter in a mailbox. So we want this to be asynchronous. So we're going to do that. And here in the properties windows, before anything changes, we've got to push the little diskette here, which saves it. And now we notice we've got the name here, and the arrow is turned to an open arrowhead. So once the visitor actually presses the button, the next thing that happens is the button lets the chime unit know that a button was pressed. So we do it again. And again, it's asynchronous. Okay, once the chime unit will begin, we'll tell the button unit, okay, I got it, start flashing. So that's exactly what we show here. So we now confirm chime is starting. Again, asynchronous. And so now the chime is starting. At this point, the button begins to flash. So the button is flashing. And okay. And now the button's flashing. And now a little bit later, the chime finishes. So we have here chime ending. And we now do that. And here next we have here, then the last thing that happens is the button goes to dim glow state. Okay, so now we have a scenario, and this one's a very simple one. This is very good and very popular with verification teams to make this kind of thing because it pretty much directly sets up your sequence of tests. Comment though I had from a young software quality engineer from the Netherlands at a conference was, she said, the sequence diagrams were extremely helpful for getting all the stakeholders on one page, but they wouldn't compile. And you'll notice there are a lot of things you can do here. This so-called sentence fragment, you can put loops in the thing and do all kinds of stuff. And her comment was, and when we added enough detail about like setting up loops within the sequence and stuff so that it would compile, the stakeholders could no longer understand the diagram. So this is the trick with sequence diagrams, is you usually, again, they're really good to fairly quickly set up some sample sequences of what might happen. Then that can be very useful for setting up a test and of course helping people understand the basic idea. But it's very hard, and in fact diminishing returns, to make sequence diagrams exhaustive. You really don't want to even try to do that because you'll end up with something that isn't very useful. The other thing that is these can be eventually tied to operations within the units, and can be signals which will cause state transitions from the state machines. So activity diagrams, aka flowcharts, sequence diagrams, and state machines, when you properly design the system, all can work together to really have a nice description, especially for multiple independent things that kind of operate like a system of systems, independently work together about what's expected about how all these different somewhat autonomous things are going to play together. So at any rate, this is the end of the quick start tutorial, which you can download. It's a little faster. I'm used to doing this in person with people asking me questions and slowing me down while I'm talking. So this went a little faster than I expected. But the good news is we have a lot of time for questions. So if people have questions, I have plenty of time to answer them, and I can show you in the tool how things work. So I think we can go over to the questions now.
Thank you, David. I thank David on behalf of everyone for making this session a wonderful one. As we said earlier, now is the time for Q&A, and we will be reading out the questions from the chat, and David will be answering them. And we can see that there are no questions asked yet, but we can wait some time for them to ask questions.
Yep,
Okay.
we can ask, and I can put this back up here. I notice we have some people who arrived late. So again, this is reviewing here. If you want to work on Sysml, you need at least the corporate version of Enterprise Architect. You can download the tutorial we just walked through here, satepress.com. And this again was about that. You can get the whole book on how to do all of Sysml, both as a Kindle. Kindle's available worldwide, and the paperback version's available in the US. I'm working on getting it available worldwide, or at least more countries. And questions can come here. I'll leave that up so anyone who wants to send a question afterward can. And you can also, as part of the conference, you can download this here. So you can go here, and this little presentation is available on the team, just right here. So that's where we can get that. So yeah, I'll be happy to just hang out here for a little while, and so if anyone has a question, I'll just be sitting here and wait for anyone who's interested to send a question into the chat.
Okay, David. David, there is a question from Long.
Okay.
That is requesting that can you show slide again for Sysml tutorial?
Oh, where to get it? This one, yeah.
And another question from Motiza. What Sysml present which UML doesn't?
Yes, that's a really good question. The current version of Sysml is built on top of UML, and in principle, you can do anything with UML. But Sysml has basically stereotypes of UML like block that are more oriented towards a wider variety of engineering. UML is very software-ish, and a block is essentially a UML class with just a stereotype name and some behaviors. But the point was to adapt the diagrams. Instead of 22 diagrams, the Sysml only has 9 to be a little simpler, and to present especially things like blocks and a few others like parametric diagrams are available for kind of doing simple simulations of a system that weren't in UML. So more oriented towards designing kind of mechanical, electronic, software systems, not just software. Yeah, probably the corresponding piece of information is who uses Sysml. There are a wide variety of users, but basically it tends to be aircraft, defense, automotive, medical devices, and trains, both the people who make the trains and people who design the train networks, the very largest construction companies, and so on. Really, oh yeah, and of course, ships not so much, except military ships. And the common denominator of who uses Sysml is extremely complex systems that no one person can really just get their head around by themselves. That's one. And the other is they tend to be safety critical, because safety critical is where you can no longer just wing it. You have to be able to prove that you know absolutely all the requirements for every piece and that they've all been tested. And Sysml is very helpful for that. Otherwise, smaller systems, ones where no one gets hurt if they don't work, people tend to want to just do it kind of in their head and not really write down a lot of documentation. They don't use Sysml. So that's where Sysml gets used, is these big complicated systems with a variety of kinds of things. That's another difference UML. UML is only between software engineers, but Sysml is between a lot of different people who will be looking at the diagrams, not just software engineers.
Okay, David. There is a question from Rocky. He said, hi, David. Can you briefly demonstrate or reframe to some resources for how requirements could be imported from Excel? I understand that EA Ultimate is required for this.
Yeah, I'm not set up to do it this evening. I don't have Ultimate on this machine. I have it on another machine. But I think we can find that probably by Googling it. And basically what it is the EA Ultimate isn't just that feature. It's generally got a lot of stuff in it to interface with Microsoft Office overall, and kind of automatically export diagrams into PowerPoint and construct Word documents, and then also move stuff back and forth to spreadsheets.
Okay, David, thank you. And there is another question from Long that with the doorbell example you illustrated, could you
Yeah.
code an actual test to simulate the functions? Example, flash when the button depressed.
Would I code a test? Or, well, I'm not sure quite what was meant, but when we did the requirements here, we showed this, and yes, this would go off, and probably in reality, the test case team would make their own models, maybe a whole model for each test. It kind of depends on what they're doing. You could do it all in one giant model, but what people tend to do, the models can be somewhat modular, and you can link between them. And so when you really do Sysml, you tend to make a core model that's the core understanding, and then the test team makes some additional model. The safety team makes an additional model, and they all link to the common center model. That's how you would do that. But this, yeah, you can actually generate code to some extent with this tool for the test case. It's possible. You can certainly generate documents, test plans with some effort. They can be made for that. Hope that answers the question.
Thanks a lot, David. Anyway, we will post all these questions in Teams as well.
Yeah.
So the audience can view there.
Yep.
Okay, David. So thanks, David. Thanks
Right.
to everyone for your time and support throughout the session. Hope it is very informative and gives a deeper insight into the topic. Now, David will be available in MS Team to have a detailed discussion and answer more questions. The link to the MS Team channel is posted in the chat window for your quick reference. If you have difficulties in connecting to Teams, please reach us out in chat window or write us at registration@daglobalsummit.com. Thanks once again, everyone, and looking forward to host you all in another wonderful session shortly. Thanks, David.
Thank you. Bye.
Thanks a lot. Bye.